Alright, so number of protons is gonna be 3. The smaller number of electrons is gonna be equal to 3, and our number of neutrons is gonna be equal to let's put 7 minus 3, and we're gonna end up with 4. If I was supposed to draw a dot and cross diagram of lithium, I'm going to put Li, and this is where the protons and the neutrons are, and I'm going to put them in a nucleus. On my first shell can only own a maximum of 2. My second shell will actually have 1. Now, looking on fluorine, where are you? That's where are you? Okay. Looking on fluorine now, fluorine is gonna look like this. It's gonna be 19, and it's gonna be 9. So looking here, we actually have number of protons is gonna be equal to 9. Number of electrons is gonna be equal to 9, and number of neutrons is gonna be equal to 19 minus 9. Come on. So yeah, treatment. And we're gonna end up with 10. This is part of a revision part. We don't have to do this part what we're moving into. So that's that. If I was supposed to draw fluorine, I'm gonna put F in the center. And then I'm gonna put 2 on my first shell. And that leaves 7. So these are electrons. And I need to put 7 here. Normally I put one at east, one at that's north, south, east, west, and then I add the rest of them until I get 7 because I want 9. 1, 2, that's 6, 7, 8, 9. Now, last time I said something to you guys. Let me show you something. Last time might have been not said to you, but tell it to somebody. So what happens is that every atom wants to look like the noble gas that is closest to it, per se. So what happens is that the closest noble gas to lithium looks like this. So helium is going to be the closest noble gas, and it looks like this. Is going to be in terms of the valence. It's going to have the thing at the center, and pretty much that is the most stable noble gas to helium. That's how things look. So to lithium is helium. So lithium actually wants to look like noble gas. Like we want to look like the celebrities that we see on TV. Now fluorine wants to look like this noble gas. So noble gas, the entire set here is noble gases. So the noble gas that is closest to fluorine looks like this. So we're gonna match a little bit. So this is how fluorine wants to look. So pretty much it wants to be what we call saturated. The outermost shell wants to have 8. So closest noble gas to fluorine has 8 on its outermost shell. The closest noble gas to, lithium has 2 on its outermost shell. What do I say now? Why did I say that? Let's see. So notice that in order for lithium to have 2 on its outer shell, this is a problem. And in order for fluorine to look like a noble gas, it's lacking an electron. So that's our problem. That's one way to look at it in terms of chemistry. Another way to look on it is that on your first shell, you need 2 to become stable. On the second shell, you need 8 to become stable. Looking on lithium, in order to become stable, would it be easier for it to gain 1, 2, 3, 4, 5, 6, 7 electrons, or lose that one black one? Which one I think is easier
to lose.
to lose? Now, look here now. This is on the other hand. For fluorine, would it be easier to lose the 7 or to gain 1?
To gain.
Gain 1. Now, this is a characteristic of this on the side. When an atom loses an electron, it is considered to be a metal. When an atom gains electrons, it is considered to be a non-metal. There's terms here, but we're not going to look at the terms. So what we're looking at here is what we call a metal and a non-metal. So we're going to talk about it. When a metal and non-metal reacts, it forms an ionic bond. What in the world is that? Alright, so I'm going to shoot this to you and in the WhatsApp, and we're going to take it from there. What in the world am I talking about? Sorry for the suspense. Hope it was worth it. So this is what ionic bond will look like. So I'm gonna send that note to everybody. We can take that on later on. Let me try to erase this. Can I erase it? I'll say this here. Alright. Just say this here. No stubborn are you? Oh, you're not that stubborn. No, I don't want it. I don't want spiritual. Alright. So what essentially is gonna happen here is that when these two atoms come into play, it will say, yo, brother, lithium. I say, yeah, fluorine. Oh, go on. Yo, lithium. You know they say you have a 1 electron there, so brother, if you give me that 1 electron there, me good, and if you lose it, you good. Where you say? And lithium must say, yo, true, you're talking about. So, true, you're talking. So lithium say, alright, I got transfer your electron here. I will normally write transfer. Can't spell the word transfer. Transfer. Come on, good. Transfer of E. I'm gonna be negative. No, this is what happened. No, no. I say, oh, let it up. Oh, go on. So I must say, when you lose an electron, so this is how we have it now. When you lose an electron there, you might have bam, bam. So you might have proton. So he's gonna have three protons, and protons are positive. And now instead of three electrons, which I'll make him neutral, you might have two electrons. So you might end up with a positive one charge. So Florida say, yo, dad, from a little that electron there, you look positive, you know? And they might, bam, and they might become positive. I might become a positive one. But look at the fluorine now. Fluorine come in now and say, all right, lithium, give me the electron there. So you might have an extra one. Bam, bam. Might have an extra one. Try it in a different color. So man say, yo, but wait, fluorine. When me get me electron like a beer crosses take you up. Like a bad mind. Cause you're negative. So what's gonna happen now? He's gonna have the same nine positive protons, and now he's gonna have 10 electrons. So he's gonna
Um,
have,
sir, excuse me, please.
go
So
ahead.
when you start class, these are the first class that keep.
No, it's the second one.
So I
My
can
last,
send the list in the group from the first class, please.
all right. My last year.
No, sir.
Oh,
Yeah.
I said, all right, I'll send it later. All right, you get that?
Um, how comes lithium lost an electron, but it's positive and fluorine is negative, even though it gained?
What's the charge on an electron? All right, one cross is ever left alive before. Hello? Answer the question. One cross is ever left alive before. When cross is left alive, you feel more positive. But when you take up crosses, you feel more negative. Make sense? Should I answer me?
No.
Oh, you never have crosses before too. All right, never mind. All right, look here. Since you don't experience that. So what happens is that these protons are positively charged here in an atom. This is a positive 3 and this is a negative 3. So when you interact with atoms, they don't shock you. So if you put this in a calculator, positive 3, negative 3, you end up with 0. Got that? So it has 3 protons and 3 electrons. Now here, he lost an electron. So he has a positive 3 and a negative 2. Put that in the calculator. What do you get? End up with? Hello? Put the calculator where you get we end up with. Answer me now, please. No, if I lost you. Young lady, you still answer me. If you don't get it, we can break it down even further.
Yes,
No,
sir. Break it down further.
alright. Let's start. Now, protons are positive, electrons are negative. If you say 3 minus 3, mathematically, that what is that equal to? 0. So in this atom, in the center of this atom, it has 3 positive charges. So it's going to have 3 positive, 1 positive, 2 positive, and 3 positive. Those are protons. The electrons now, this is 1 negative, 2 negative, and 3 negative. Now, what happens is that if I have 3 positive and 3 negative, there's no charge on it. In order to get a charge, I have to have a difference. So if you touch a piece of board right now, all of board have bonds, you're not gonna get shocked because the number of protons and the number of electrons would be the same. Got that? So now this is called an atom and they're neutral. Now within the center of this now, the lithium, it still has 3. 1, 2, 3. Those are 3 positive, and now it have 2 negative. 1 negative, 2 negative. So mathematically, if I have positive 3 and I have only 2 negative, I'm going to end up with an overall of a positive 1. Does that make sense to you? I'm going to ask it. Same way. Answer no? Hello? Hello? So
Yes,
electrons,
sir.
we lose you?
No,
Make more sense?
a lot more.
So what happens now? Him on the other hand now, when him send across a negative charge to him, but he was neutral, he was at 0. So what in the center of him here, he has 9 positive, and him take normally him have 9 positive and 9 negative, therefore he was at 0. But when him take up one more negative on himself, he becomes negative overall. Got that?
Yes, sir.
So what's gonna happen? What's gonna happen now, you still won't get shocked if you touch this. Reasons being is this. Don't do that. You're still not gonna get shocked because why you think you won't get shocked if you touch this? Look at lithium now. Lithium has an overall of a positive 1 and fluorine has an overall charge of negative 1. In chemistry, opposites attract. What do you think that means? Just like in the universe, you'll have male attracted to female and female attracted to male. That's how chemistry functions. We have female attracted to female and the entire 9 yard, but in chemistry, they follow opposites attract. So what's gonna happen now is like, yo, lithium, remember say me give you my electron, you know. So I may have to stick to you. I'm gonna say, all right, fluorine, I'm gonna stick to you. So this positive charge, this lithium now, it's gonna be called an ion. It's no longer called atom. This lithium ion will be attracted to that fluorine ion, and we have two ions coming together, and that's why it's called ionic bonding. And if you're looking at your chemical formula, you have one lithium, one Li, and one F. So therefore, the chemical formula of lithium fluoride is going to be LiF. Let me put the word lithium there, just in case of give me a second. So this is going to be lithium, and this is going to be fluorine, and this is going to be called lithium. Make sure.
So does lithium fluoride not have a charge like together?
No, it doesn't. The positive, they cancel each other. That's my young people in my class. And this here is called the chemical formula. And that's our first ionic bond example. Take it down. I want to look at one more. Let's go through it again. Ready? Lithium is going to be drawn like this. Lithium, this 3 here, indicates the number of electrons in lithium, and it also indicates the number of protons. I don't have to draw the protons in the center for chemistry, but I'm going to put the electrons on the outermost shell. Now, this is called the valence shell. I didn't mention it. And what happens is that lithium does not feel stable. It doesn't feel like, yo, I feel like I want to give away this electron. In giving away this electron, it feels that it's gonna feel more stable. Now, fluorine is in the area, and fluorine has 1, 2, 3, 4, 5, 6, 7. It needs to gain one. So lithium says, hey, guess what? Fluorine holds on to this electron for me. Electrons are negatively charged, so it loses a negative charge and it becomes a positive charge because it loses one electron. Therefore, the overall charge on this ion now is not lithium atom, it's going to be a positive one. When fluorine gains a negative charge, it's going to become negative because it was neutral. And then since for this equation, since there's one lithium atom and there's one fluorine atom, we'll just put that together and say the equation is going to be lithium fluoride, not fluorine. I think I spelled fluorine wrong. Let me correct that. Yeah, I spelled fluorine wrong. Um, so this is gonna be. Nobody's gonna ask me a question. Why do I call it fluoride instead and not fluorine anymore? So when it's bonded, we give the non-metal, we call it ride instead of. So we're if you look at, I don't know, you guys must have heard about chlorine. If I react chlorine something, it's not only called chlorine. On its own, it's gonna be called chlorine. But when I react it, I'm gonna call it chloride. So just like we have fluorine, when it react, when it after it bonds, we're gonna call it fluoride. So that's the difference. Take a time, take a 5 minutes, ask yourself all the questions you want to ask, and let's try another one. I give you 5 minutes to look at it. Pretty good. All right, guys, are you finishing that now? Hello.
Yes, sir.
All right. Anybody ever heard about NaCl?
Yes, sir.
What is that?
Sodium chloride.
No, wait, name. Common name.
A salt.
Stable salt. You know, salt is like an entire group of chemicals, right?
Yeah.
Yeah. So if it's a salt, it's an entire group. All right. So let me show you something again. So we're gonna look at table salt. Salt we put in their food. And last class we talked about group one elements. So every element in group one has, and that's group one, has one electron on its outermost shell. I want to lose one electron. Therefore, it's gonna be a metal. Now we're gonna react it with chlorine. Those are chlorine and fluorine are in the same group. Therefore, they have 7 electrons in their outermost shell, and it's still gonna the diagrams are gonna look alike, but you're gonna have more. Well, you're gonna have more shells because this is in period two, therefore it has 2 shells. This is in period three, therefore it's gonna have 3 shells. Revision from last time. So we're gonna look at sodium, which is right here, and it's chlorine. And notice that here these are metals, go all the way here, and these are non-metals. So we know that if we're looking at the periodic table, this is an ionic bond. So that as well. So before further ado, let's start. Um, did I send that to you? I don't remember. I don't think so. So this is salt we put in our food every day. Ooh, that didn't work as I wanted to. Yeah, we'll see. So we're looking on, and the symbol for sodium, you can look at our periodic table. Our mass number, which is a bigger number, is going to be 23, and it's going to be 11. And the symbol for it is Na. And what's going to happen is that we're going to call it sodium. And the other one,
Sir,
yeah.
we're not seeing
We're
anything.
not seeing anything.
Oh, like the screen. That's awful of me. See my screen now, right? That's sodium.
Yeah.
You can check our thingamajig. Where are we? I'm trying to get something off. And chlorine is gonna be 35.5. Anybody's gonna ask me? 35.5. Nobody's gonna ask about 35.5? Alright, let me see. And this is gonna be chlorine. Double check. Okay, good. Well, that's chlorine. Alright, that is that. Let's look on. You can skip about the number of protons, neutron, and electron. We're just gonna look at this number. I want to know that there's a number of protons. We're looking at an atom, number of electrons, so we can draw that. So we're gonna put sodium in the center, and we know it's neutral as well. So it's gonna be sodium Na, and we're gonna just fill out the shells. We're gonna put one shell, and we're gonna go up to 11. So now the first shell holds a maximum of 2. The second shell holds a maximum of 8. That's 2 and 8 is 10. But we want 11. And I'm gonna end up with 3 shells. Therefore, E wants to lose 1. So his outer most shell would actually have 8. Chlorine of 17. I'm gonna draw it next to it. So it's gonna be Cl. It's gonna be big. So there's gonna be a nucleus. It's also neutral since it's an atom. 2 on my first shell. We use dots for this one. So it's called a dot and cross diagram. Um, I'm gonna have 8. That's gonna give me 10. But I want 17. So it's gonna look like this. These are my electrons, my negatively charged um, subatomic particles. And my last shell, somebody saying something, mic is open, is gonna have 7. So 10 and 7 give me 17. And that's our reaction.
Sir, can you mute that person?
I don't hear.
Can you mute the person because I can't really hear?
There you go. So that's the 11 right here that I use, and I draw the electrons, and the 17 here I use and I draw that electron there. Look at that. Any questions regarding that drawing?
No.
All right, good. What's gonna happen is that this electron will be transferred right here, and we're gonna have a trans, sorry, transfer of electron. And please note, it's a negative charge, so we're giving it a negative charge, so it's gonna gain a negative charge. So now our new sodium is gonna look like this. It's gonna be, what did I do? Wrong thing. No, something wrong. My new sodium is gonna look like this. My sodium ion. I'm gonna tell you what it's called later on. The positive one is have a special name, and the negative one have a special name. Both of them are ions, so it's gonna have. And now, um, and now it loses that one. It loses a negative charge. Therefore, it has a positive charge. So it loses something and become positive. Because what it lost. So we're gonna put, and we're gonna say, yeah, we know it's negative.
Wait, so sir, um, is it that always when an element loses an electron it becomes positive?
Yes,
Or is it just okay. And the other becomes negative when it
when it gains.
gains?
Yes. And now he's gonna gain one. Sorry, it was a dot. We're using dots. And then ha on the last shell. So it's called dot cross. I normally do with dot and cross. I think this is gonna be easier to see. So it's gonna be that and this cross coming down. So we know that cross is coming from that. So now he becomes I'm positive. I'm writing negative. More space. That's negative. And now the formula for this is going to be Na. So there's one sodium, Cl. And their names, the name of this compound is going to be sodium chloride, NaCl, table salt. Again, take a look at that, take it down. Let me know if there's any issue. All right, guys, ready? Have I lost anyone? All right, no, we're gonna take it a step further. Ready? Now, that was just weird. Look at this now. I know you're not seeing my screen. I'm changing something. So far, we have been using these ones. I'm gonna stick. We've been using this group number one. I know that they have one electron on their outermost shell. I know that these guys need one. So I've been keeping it simple. Ha! What if I use magnesium and chlorine? So I'm gonna look at magnesium chloride. How would that look? Notice that we're no longer in group one, we're in group two. So without even drawing magnesium, we should know that magnesium has two electrons on its outermost shell, or you see the valence shell. Let's see how that plays out. We're gonna get magnesium and chlorine, we're gonna write them using a dot cross diagram. And we also know that magnesium belongs to this, therefore it's it's the word here, alkaline earth metals, so we know it's a metal. And we know that this the is our it's a special group of halogens. So we know that that's a non-metal. So we're still looking at on an ionic bond. So we're gonna look at magnesium group two, chlorine group seven. We know what's gonna happen already. Ish. But let's see. So let's draw that. Magnesium chloride. It has same listing. Right click on making a mistake. Getting old. Yeah, so the chloride. We're gonna look at magnesium chloride now. Make them. Alright. So oh gosh, that yeah, kinda just erase my periodic table. Alright, so I want you. Right here I want you. Alright, so it's gonna be Mg, so it's gonna be 24, 12, we're gonna do Mg, we'll do magnesium, we're gonna have chlorine, which is gonna be 30, 35.5. Nobody's asking about the 35.5. I guess it doesn't bother them. If you don't ask, I will tell. I have to tell you eventually, but I guess not tonight. Alright, so that's magnesium and chlorine. Let's see how does that look. Let's see now. I'm not gonna write word magnesium. I can't write magnesium for me. I can't spell magnesium right now. So magnesium is gonna be we have 12 right here. So this 12 is gonna indicate that we have 12 electrons. So we're gonna go Mg, like a good G. Wonder if I have enough space. So it's gonna be cross. Let's use cross for this one. That is 2 on the first shell. We're gonna have 8 on the second shell. That's 2 and 8 is 10. That leaves 2. And we're gonna have 2 on our last shell. That's gonna be 10 and 2, 12. I'm gonna put them apart. Electrons don't like electrons sometimes. Now let's look at our chlorine. Copy and paste this one. Because I know what's coming. Put it right here. If I can't hold. So this is gonna be my chlorine. It's gonna be two. Sorry, I'm gonna use dots. I should be using dots. Don't really matter. Just for shenanigans, it's gonna be 8 on my second shell. And I'm gonna have 7 on my last shell. Now let's look at what happens. When I have a transfer of my electron right here, and this one goes here, transfer of electron, we know is magnesium. Magnesium still doesn't have, magnesium did not get rid of the last shell. It still lacks, it still have this one electron. So it's still lacking. So let's say, boy, wait, what going on? So what's gonna happen now? I need another chlorine to come in and take this one. So we're gonna have transfer of electron, and this is what we're gonna have. Um, um, one second. Let me clean this up. It's gonna be this shell won't exist because there's no electrons in it. And what we're gonna have is this.
Sir,
Yeah.
someone asked why chlorine's mass number is 35.5.
All right. Well, we should look at that. So what's gonna happen here? This. Now, magnesium. What do you think the charge on magnesium is? It lost 2 electrons. What do you think the charge on magnesium is?
Plus 2.
Yes, that's correct. So magnesium lost 2 electrons. So it's in black. And chlorine, each of them only get, right, my team put no electron on it. So 1 electron per here, so, and 1 electron per here, so. And chlorine only gain 1 electron each. Therefore, this becomes -1, negative, and this becomes negative. What do you think the formula is gonna be?
What do you mean? Like combine?
Yeah, combine them. What do you think the formula is gonna be?
Um, MgCl2.
All right, correct mundo. Now we're it's gonna be we're gonna write Cl, and since there are two of them, we're gonna put the two, there are two as a subscript, so it's gonna be a two at the bottom. So this means that in the formula for magnesium chloride, you're gonna have one magnesium atom and two chlorine atom, and that's how you get chemical formulas. And in words, this would have been magnesium chloride, and that's also an ionic bond. And it's also a salt. All right. Somebody asks why we have this being 35.5. So what happens that in nature, don't look on it. In nature, we have in nature we have several different type of atoms, and they're called isotopes. We're gonna look at that later on. For hydrogen, we have three hydrogen: hydrogen one, hydrogen two, hydrogen three. Um, for carbon, I think there are three carbon: carbon 12, carbon 13, carbon 14. And for calcium, what is calcium? For chlorine, we have we have two chlorine. We have what we call chlorine. I think it's gonna look like this. It's gonna be chlorine. We call this chlorine 35. So it's gonna look like this. They're gonna look the same. And we're gonna have chlorine 37. The thing about chlorine is that in terms of the abundance of chlorine, the two isotopes, so they're the same chlorine, one is heavier than one, is that there's so much abundance of these two chlorine, we just pretty much depend on the percentage we find in air, we add them up and take the average. And we'll take the average, we end up with 35.5. That's what we do about one number. Because there are two chlorine abundant in air, and we look at the percentage. I think this one is 30%, and that's 70%, and we just max it out, and we get an average of 35.5. So later on, we can look at isotopes. Look at that. What are isotopes? So several compounds are the same. So that's why I have 35.5. We have two chlorine that occurs naturally. One is 30%, one is 70%. And when we look at the average between them, we end up with a atomic mass of 35.5. So when you interact with chlorine, you don't know if it's chlorine 37 or you don't know it's chlorine 35. So what we do, we just get an average. So guess what? The chlorine you're interacting have a average mass of 35.5. Make sense? Yeah. All right, take that down. in a services group? Hmm? Is there a physics class in you? Is there a physics class in you? Somebody said, "Sir, um, the student should be in physics class this evening, but has not received an invitation." Maybe, yeah. When I inform about that, mm-hmm. Started my church class on Tuesday. Hmm? Yeah. Mm-hmm. He said, Miss Johnson, man, I remember that. We got Marco. I started the year ago. I started the year ago. I didn't think so. They were got to do it all. I didn't think so. They were got to do it all. Hmm? Well, churches are going to attain university status. After all, my getting it. Churches, teachers, college, and course attain university status. University, college, and a university. All right. Are you ready?
No, not yet.
Oh, Alright, so I'm gonna ask to draw. Let me finish. Let me not rush you guys. Mom, no, look here. Look here. Look here. Calm down. Yeah, come back to the phone. Calm down. Okay, simple. Ready?
Yes,
People.
sir.
Alright. This which one I give you? I give you lithium chloride. Anyway, let me give you one. What if I get? I keep on doing that. Um, let's do that. Give me a second. Hey, yo, I just like America or something. I go online. I think people are about bro. I think people are brushing their teeth in the online class. All right, give me a second. Okay, where were we? You can use our periodic table to have an idea of how this look. So we're gonna look at lithium, Li, and it's gonna be 7, 3, and we're gonna react it with chlorine. That's 1, and it's gonna be 17. And hmm, let's give it beryllium. not the company. And let's give it fluorine. So my question, so this is gonna be one set. So my question is, make a dot and cross diagram for the ionic bond for the following atoms above. So same way with I did it, it's gonna do that way as well for both of them. So try that, try the first one, and when you're finished, we'll try the second one. So I'm gonna give 5 minutes on the first one and another 5 minutes on the second one. You guys are finished? Hello? Hello?
Yes, sir.
Finished?
Yeah.
All right. So let's look at this one. So lithium, it looks like this. Right, dot cross diagram. So you're gonna have lithium. It's gonna have three electrons and one valence electron. And we know that chlorine only needs one. So it's gonna be like that. It's gonna be 7 on its valence shell. We're gonna have a transfer of E, 10 trans, sorry, I'm not seeing it. Transfer of electron, negative E. And we're gonna end up with this scenario. Just copy and paste. We're gonna end up with this scenario. I didn't need that. Why are you doing that to me? Okay. So, ah, did I do? It's not control Z in. Like seriously, all things righteous. Oh, I'm lagging. Wait a second. I'm lagging badly. Oh, no idea what that's supposed to be. Alright, let me copy again. Press something I should not press. And we're gonna end up with this scenario. This shell will be gone. And lithium will have transferred this electron here. And this is gonna become negative. And this has become positive. And that's gonna be positive. And if you want a formula, lithium chloride. And that would have been the first one. Anybody had difficulty doing that one?
No.
So other one. All right. Other one. Same thing gonna is gonna be beryllium, right? Fine beryllium. Is gonna be this Be is gonna be 9, so it's gonna be 2 linear pressure. It's gonna be 4 linear pressure and 2 under support. Fluorine is gonna be 9, 2, and so a dot. These are electrons. A dot. 1, 2, 3, 4, 5, 6, 7. One would one we want to go here. And we still have another one. Transfer of electron. It's gonna be easy. And Control C, Control V, and one will go here. Another transfer of electron. Transfer of electron. Let's go wrong. Yes, transfer of electron. Transfer negative electron. So what's gonna happen is this. Oh, I see what happens. Copy. Paste. This will be erased. And what's gonna happen is that this would have gotten an electron. This would have gotten an electron. And this would have lost 2 electrons. So it's gonna be um plus 2, and this is gonna be minus. And these are gonna be attracted to each other because plus and minus opposites attract alike well. And these are very, very, very strong bonds, like extremely strong bonds. It's gonna be B. Chemical formula will be BeF2. So there is one Be and 2 fluorine. All right. Now take that down. Very cool.